Okay, welcome to the lesson on composite functions. Today we're going to talk about composite functions, and the reason why we are using composite functions is understanding the rules of inputting and substitution. This helps us a lot with, like I said, with substitution and plugging values in. So with composite functions, you're always going to have two functions. And I'm labeling the first one. I'm going to give an example. F of x equals 3x. That's in blue. And then in green, it's gx equals x plus 2. Now, the composite symbol, if you look in part A, it's f, you would say, of g of x. So what this means is the first letter or the first function represents what I call the main or the parent function. And we will input or substitute the second function, in this case, in part A, it's g, back into the main one. So we're going to use rules of substitution. So what I want to do is I'm going to show us what I mean by that. So when you see in part A, f of g, that means f is right here, our main function, and our g is the function we're going to substitute in. So what I'm going to do is I'm going to circle x plus 1, and I'm going to plug it back in for x. It's just substituting in for x. So by doing this, that means I'm going to try to keep this color-coded. That means the f is function is 3, but then what I'm doing is for that x, I'm substituting in the x plus 1. Now, to finish this up, you just distribute the 3 to the x plus 1, and the answer that I'm looking for is 3x plus 1. Now, like in all of my videos, I always urge us to pause the video, give yourself some time to work it, unpause it to check your answers, and you can always repeat these lessons. Now, in part B, what I've done is I went ahead and rewrote the g of x and f of x functions, but now in part B, now g is the main function, and f is the one we're going to substitute in. So what I'm going to do now is I'm going to take this 3x from f, and I'm going to plug it in for that x in my g of x function. So that means that x is really now comes 3x, but I still have that plus 1. So in this case, my answer is 3x plus 1. Okay, now, one common mistake is, and I'll kind of make a little note right here at the side, is on any of these, let's take a look at like part A right here. You don't say 3x and then x plus 1. That is the common mistake. What happens is that x on part A is substituted for x plus 1, so there's not an x there, so that's why it's 3 and then x plus 1. Now in part C and D, I give you the composite, but what I'm giving you now is a value of 2 on both parts. So what we're going to do on both parts is this. I'm going to take my 3x plus 1 on both of my answers. Now, this is just one of those strange coincidences. Not all of these will be the same answers in part A and B. So what I'm going to do now is I'm going to take that 3 multiply by now by this 2. That 2 is where my x value is. In this case, it's in both. And then what I'm going to do is I'm going to go ahead and perform the operation. Say, okay, 3 times 2 is 6 plus 1. That's 7, and that's 7 on both. Okay, like I said before, if you need to review this, just go back and repeat it. Now I'm going to give you a second to look at this one. It's the same kind of format of color code. I like color coding. And just remember, like in part A, when we're looking at this is taking our function f, which is what I call our main function. And what we're going to do is substitute the g value back into it, wherever you see the x at. Now, so on this one, what I'm going to do is I'm going to go ahead and I'm going to say, okay, since f is my main one, I'm going to take my g, which is 4x plus 1, and I want to substitute that in for that x. So now what that f is, that x turns into 4x plus 1, and I still have that minus 7 there. Next, we just need to combine like terms. We don't have anything to do with this 4x, but we can say 1 minus 7, which is a negative 6 or a minus 6. In part B, now the g is the main one, so I'm going to take this x minus 7, and I'm going to plug it in for that x. So I still have that 4. But now I'm substituting in x minus 7, and still in that first part, I still have that plus 1. Now we're going to distribute, and we're going to say 4 times x is 4x. 4 times, you can treat that as a negative 7 if you want, and say that is a negative 28 or a minus 28. And then we still have that plus 1 on the outside. So when we combine these, our answer is going to be 4x minus 27. Part C, since I know my value of 2, I'm going to take that 4 from my answer, 4x. I'm going to plug in the 2, and I'm going to subtract 6. So 4 times 2 is 8. And then 8 minus 6 is 2. Same thing with should be part D. In part D, what I'm going to do is I want to take, since that f of g of f is the same as b, but now I've got that value of 8, what I'm going to do is I'm going to take 4 from my answer in b, I'm going to plug in that 8, minus 27. So 4 times 8 is 32, then minus 27. And that gives me the answer of 5. Now part 3, instead of using g of x and f of x, I'm using m of x and n of x. So I want you to push pause, see if you can work this out, then come back to it and see if you are correct, and see what mistakes you may have made. Now, like I said before, I like to color code. So my m in part A, my m is my main one, so I'm going to substitute this 2x plus 3 back into that x. So basically I have the 5, then in parentheses I'm putting the 2x plus 3, but then I still have that minus 4. So now what I'm going to do is I'm going to go ahead and distribute the 5 to both. So 5 times 2x is 10x. 5 times 3 is a positive 15. I still have that minus 4. So my final answer is going to be 10x, and then 15 minus 4 is a plus 11. Part B, my n is my main function. So I'm going to take in my 5x minus 4, and I'm going to substitute that in for that x in green. So now what I have is I still have that 2, but then in parentheses, I've got my 5x minus 4. But still from that first part of the main function, which is n, I still have that plus 3. So now what I'm going to do is I'm going to still distribute. Then 2 times negative 4 is negative 8. I still have that plus 3. So now what I have to do is the only thing I can combine are the numbers. I can't do anything with the 10x. So it's going to be 10x minus 5. Now in part C and D, I've got the values. You just plug them in. So since I know m of n comes first, that's why C is matched up with A. Always look to make sure you're getting the right one. You cannot put part C in the answer for part B or it will be incorrect. So now what I want to do is I want to take my 10x from my answer in part A. I'm going to plug in the 3, so 10 times 3 plus 11. 10 times 3 is 30 plus 11. You'll get a grand total of 41. And then in my last one, I've got this negative 6. I'm going to say 10 times negative 6 minus 5. Well, that gives me 10 times negative 6 is negative 60 minus 5. So since both of them are negative, that means if you owe me 60 and owe me 5, you owe me negative 65. And finally, I'm going to put in exponents. Like I said before, please pause this and come back to see if you've done this correctly. Okay, so now I've got this f of x is x plus 3 and g of x is x squared. So in part A, all I'm going to do is substitute x squared in for x. So that x I'm going to replace by the parentheses. I'm going to put x squared in, and I still have that plus 3. So my answer is just x squared plus 3. Now I know in my previous classes that I've taught, they're very surprised how simple this answer is, and they can be simple. Now in part B, now G is my main one. So I'm going to substitute x plus 3 in for that x. So that x, I'm going to put parentheses x plus 3, but I still have that I'm going to come back to part B here in a second. I'm going to show you something else you can do with this, but for my purposes only, what I want you to do now is part C is all I'm going to do is I'm going to substitute that 11 in for x and square it in plus 3. So now 11 squared is 121 plus 3. You should get a grand total of 124. Now in part, let me show you this. In part D, all I'm going to do now is I'm going to substitute the 42 in for x plus 3, but now I'm going to square it. So that is like saying 45 squared. So if you square 45, you should get 20. You should get 2025. Okay, now I'm going to come back to part B for a second, because sometimes what we do is when you have this x plus 3 squared, this can be the same as x plus 3 times x plus 3, which if you FOIL it, you got x times x is x squared, x times 3 is plus 3x, and go under, another plus 3x, and then 3 times 3 is 9. If you combine them, you would say x squared plus 6x plus 9, or, like I didn't change this, the x plus 3 squared would be an answer that you could substitute the 42 in and not worry about it. Now, for my Math 150 class, what I want you to do now is I want you to go ahead and work on your study guide number 1. Thank you for listening.